Okay, ran out of film, I'm back. Alright, we defined solubility, and now we need to talk about what a saturated solution is. A saturated solution. Saturated solution is a solution in which the maximum amount of solute has been dissolved. A solution in which the maximum amount of solute has been dissolved. So our example of sodium chloride was 37 grams of sodium chloride in 100 grams of H2O. That would be a saturated solution. Make sure I got this focused. A saturated solution. What is a supersaturated solution? A supersaturated solution, a solution that is able to leap over tall buildings in a single bound. No, a supersaturated solution is a solution in which more than the maximum has been dissolved. What? How can you have more than a maximum? A solution in which more than the maximum has been dissolved. Oh, how on earth can I have more than the maximum? Well, the key lies to the hint that I gave you a little bit ago about standard temperature and pressure, right? The solubility is measured at standard temperature and pressure. So if standard temperature and pressure is adjusted, you can actually get more than the solute into it. Some things that you can do to adjust that solubility, what affects solubility, is the following. Keep this in mind. I'll erase it. For a solid, if you increase temperature, you will increase solubility. And that's the way you get a supersaturated solution. So I take my 100 grams of water and I increase its temp to, say, 120 degrees rather than 100 degrees, which is standard temperature. If I increase it to 100 degrees, I can increase the solubility of sodium chloride. Right? So I'll increase the solubility of the solute. So I could take maybe 75 grams of NaCl and dissolve it, and I just made this 75 gram thing up. 75 grams of dissolve 75 grams of NaCl in 100 grams of water. Now, what happens when you lower this temperature? So you heated it up, you dissolved it. What's going to happen when that solution cools back down? Well, one or two things can happen depending on how much you supersaturated it. If you really supersaturated it, crystal formation is going to start to happen. And what crystal formation looks like, if you've ever done one of those goofy little things you put in water and it looks like it grows crystals in water, that's what's going on. You heat it up, you dissolve it, and when it cools down, all the crystal stuff falls out of the water and starts to grow crystals. And that's what's exactly going to happen here. If you cool this back down, the crystals of sodium chloride will begin to form. Now, each crystal, amazingly enough, every substance has a unique crystal to it. All right, so that's one thing that can happen. begin to form. Another thing that could happen would be nothing. If you just barely supersaturated the solution, that extra saturation will hold until you drop one more crystal in. And once you drop that one more crystal in, it's all going to fall out. Okay, that's a solid. What about a gas? Gas. For a gas, if you increase the pressure, you increase solubility. Or just the opposite, if you decrease pressure, you decrease solubility. And we see this when we open up a Coke, right? So when you have a Coke, there's dissolved carbon dioxide in it. And when you pop the top, you hear tsh, and you get the foam and you have a release of carbon dioxide. And the reason that's released is because you decrease the pressure by opening up the can. You open up the can, decrease the pressure, the dissolved carbon dioxide is then released into the air, and you get that little psh thing going on. All right. What else? They talk about, incidentally, for a liquid, there's nothing you can do that's going to increase the solubility of a liquid. Liquids are sort of impervious to that altering standard temperature and pressure. So nothing is going to increase the solubility of water. Increase or decrease waters. I'm sorry, not water, liquid. Liquid solubility. What else? All right, the last thing we need to talk about is molality. Molality, not molarity. Molality. Molality. And it's spelled molality. And this is a measurement of solute, the solute versus kilograms of solute. It's basically moles of solute over kilograms of solvent. All right, so if I have 2.3 moles of NaOH and I dissolve that in 1.2 kilograms of H2O. What is the molality of that solution? Well, you're going to take 2.3 moles divided by 1.2 kilograms, and it's going to equal 1.9 molality. It has a molality of 1.9. Sorry, NaCl. Molality, you're not going to get mole-to-mole ratio stuff for molality. I can't really think of a time that I actually used molality. Yeah. All right, and that's it for Chapter 11. There's freezing point depression, which you can look at, read about. I'm not going to test on, which is the same as saying don't look at it. So you're looking at Chapter 11 up to freezing point depression, which is page 369. Take a look at all that. Really, there's nothing in Chapter 11. Chapter 11 goes from page 354 to read to 369. Just take a look at it. And we will talk again. Very good. Hope you all feel better.